Hello friends, this is Gangadhar from Maths Kanda. See, now in this mathematics session we are going to discuss the top 10 conceptual ideas from trigonometry. See, we have a playlist in our channel related to the top 10 conceptual ideas for mains. For every chapter, I am giving top 10 conceptual ideas which helps you most in scoring the JEE mains examination. And repeatedly I am telling you that you have to utilize all these videos under this top 10 conceptual ideas as a revision part or as a formula sheet. You need to utilize these videos for the regular class, for the complete syllabus and the complete chapter. You need to go with the concepts of mathematics, another playlist of our channel, right? So now this is the turn of trigonometry. Here we are mentioning the top 10 conceptual ideas, and you need to utilize these as a preparation for your JEE mains, right? And among these top 10 conceptual ideas of the trigonometry, this is the first conceptual idea. And look here, the first one is, if the angle theta is acute, then for the acute angles of theta, how can we define the trigonometric ratios, sine, cos, tan and everything? See, if the theta is acute, then you need to consider a right angle triangle in which that acute angle is included, right? See, for every acute angle, for sure there is a right angle triangle in which that theta is included. So you need to consider such triangle. In such cases, I think you are all familiar with the basic definitions. If theta is acute, sin theta is the opposite side by hypotenuse. Note that this is the opposite side of theta and this is the hypotenuse. So sin theta is opposite side by hypotenuse, cos is adjacent by hypotenuse, whereas tan is opposite by adjacent. In the similar fashion, if you look, see, cosecant is hypotenuse by opposite. That in the sense it's just a reciprocal of sin theta, right? The same way secant is hypotenuse by adjacent, reciprocal of cos, whereas cot theta is the adjacent side by the hypotenuse and which is the reciprocal of tan theta. This is the subbit of the first conceptual idea, right? Under each conceptual idea, under these 10 conceptual ideas, I am giving you some subbits. If you are perfect at all these 10 conceptual ideas, including with the subbits, then automatically you will score good marks in the, or you will score good rank for the JEE mains examination, right? And look there, the second one is memorizing the, recalling the values of the trigonometric ratios for the very known basic angles, on which are 0 degrees, 30 degrees, 45 degrees, 60 degrees and 90 degrees. I think you are all familiar. For sin theta, what are the values? For sin theta, the values are, see, sin 0 degrees is what? 0. Sin 30 degrees is 1 by 2. Sin 45 degrees is 1 by root 2. Sin 60 degrees is root 3 by 2. And sin 90 degrees is 1. For sin, you need to memorize. And for cos, if you need, for cos theta, you just reverse all those things. Cos 0 degrees is 1. Cos 30 degrees is what? Root 3 by 2. Cos 45 is 1 by root 2, cos 60 is this 1 by 2 and cos 90 is 0. All these are the very basic things of trigonometry. I think you know all these things, right? Yeah, after having sin theta and cos theta, just if you divide sin with cos, then automatically you will get the values for tan. So tan 0 degrees is 0 by 1, 0. Tan 30 is this ratio 1 by root 3. Tan 45 is this ratio 1. Tan 60 is this ratio root 3. Whereas tan 90 is this ratio, which is nothing but infinite or undefined value. Right? So after having sin theta, cos theta, tan theta trigonometric values, we can easily reciproc each and every angle, and you will get the values for these cosecant, secant and cot. Right? Yeah. And then the next thing, this is also comes under the basic chapter of trigonometry. The identities like sin theta into cosecant theta is equals to 1. Since these two are reciprocal to one another, for sure their product is 1. And cos theta into secant theta is 1. Whereas tan theta into cot theta is 1. See, these three identities are true in many angles of theta, but they fail in some situations. See, you need to memorize all those situations also. Sin theta into cosecant theta is equals to 1. It is true in 99% of the chances, but it fails in one chance, where if the theta is an even multiple of 90 degrees. For suppose if theta is 0 degrees, sin 0 degrees is 0, you know it. Cos 0, cosecant 0 degrees is the reciprocal of 0. See, 0 when multiplied with reciprocal won't give 1 in mathematics, right? So sin theta into cosecant theta is equals to 1 is not true for theta is equals to 0 degrees. Similarly, this first identity fails for 0 degrees, 180 degrees, 360 degrees, like that. So you need to memorize that sin theta into cosecant theta is equals to 1 if theta is not equals to even multiples of 90, like 2n pi, right? 0, 180, 360, for all those angles that identity fails. Whereas cos theta into secant theta is equals to 1 also fails if theta is not equals to 2n plus 1 into pi by 2, right? So here I need to say not 2n pi, 2n pi by 2, right? Even multiples of pi by 2, 90, whereas this is the odd multiples of pi by 2. That in the sense for 90 degrees, if you say, or for 270 degrees. For 90 degrees, cos 90 degrees is how much? 0. Whereas secant 90 degrees is again its reciprocal. 0 into its reciprocal value can't be 1, right? So this is true in many cases, but it fails in some situations where the theta is an odd multiple of 90. So you need to memorize that cos theta into secant theta is equals to 1 is true for all the values of theta, and if theta is not equals to the odd multiples of 90. Whereas this tan theta into cot theta is equals to 1 also fails if theta is a multiple of 90. Either it may be even multiple or it may be odd multiple, for sure it fails. So this is true if theta not equals to n pi by 2. In all the other cases it is true. So see, easily you can memorize these identities, but you need to memorize these restrictions also on these identities. Alright, along with this C bit, you have another one, very fundamental identities. Sin square theta plus cos square theta is 1, secant square theta minus tan square theta is 1, and cosecant square theta minus cot square theta is equals to 1, right? I think you know all these things. From this, easily you can manipulate. You can prove many other identities, okay? Like secant square theta is what? 1 plus tan square theta. Cosecant square theta is what? 1 plus cos square theta, cot square theta. And a similar fashion, see from there, secant square theta minus tan square theta 1, you know that secant theta minus tan theta into secant theta plus tan theta is 1. That in the sense secant theta minus tan theta and secant theta plus tan theta, and these two are reciprocal to one another again. And if you know any one value, then automatically you are able to give other value also, right? And for these two identities also, there are some restrictions like this. You need to think all those things, right? In the first conceptual idea of trigonometry, I am going to give you one more subbit, and you may say it as E of 1, right? See, everything comes under the first conceptual idea, the very fundamental basics here, okay? And the E bit involves with some more identities, which are also very useful like this, and those identities are like this. Secant square theta plus cosecant square theta is equals to secant square theta into cosecant square theta. See, think about it. Secant square theta plus cosecant square theta is equals to secant square theta into cosecant square theta. Easily you can prove this using the first identity, and this is again useful in many branches, not only in trigonometry, in some other areas also this identity is helpful, okay, in many problems. That's why you need to memorize this. Secant square theta plus cosecant square theta is equals to secant square theta into cosecant square theta. Similar to that, we have two more identities, and another one is tan square theta minus sin square theta is equals to tan square theta into sin square theta. Look at this. This is the minus sign, and this is the multiplication. The difference between these two, tan square theta and sin square theta, will become the product, tan square theta into sin square theta. Whereas another one is cot square theta minus cos square theta is equals to cot square theta into cos square theta. We can prove these three identities using these three, and all those things are very helpful in solving many problems, right? As I told you, you need to utilize all these things as a formula sheets for the trigonometry or as a revision schedule, right? Just have a look at this. This is the first conceptual idea from trigonometry. And now, this is the second conceptual idea from the trigonometry, and this includes involves with the formulas of compound angles, right? We know that sin of a plus b is sin a cos b plus cos a sin b, and sin of a minus b is sin a cos b minus cos a sin b. Similarly, cos of a plus b is cos a cos b plus, see, for plus sign you need to utilize minus here, right? So cos of a plus b is cos a cos b minus sin a sin b, and cos of a minus b is cos a cos b plus sin a sin b. And tan of a plus b and tan of a minus b. Look at that, tan of a plus b is tan a plus tan b by 1 minus tan a tan b, and for tan of a minus b, in numerator you need to take minus, whereas in the denominator you need to utilize plus sign. See, have a look at this. For sine, the same symbol you will get in the result. for cos, you will get the opposite symbols, right? Yeah, and after having these compound angles, you can solve many questions actually. And but now we are just mentioning the things which are helpful to solve the problems. And using this, if you multiply the first two, look at that, sine of a plus b is this and sine of a minus b is this. If you multiply the first two, what will happen? So you need to think about the first two. If you think about the first two, on adding, these two terms will get cancelled. So sine of a plus b plus sine of a minus b is equals to 2 sine a cos b. Whereas if you subtract, the first terms will get cancelled and results outside as 2 cos a sin b. Those are also very helpful. Once again, I am repeating you. Sin of a plus b plus sin of a minus b, the sum of these two is 2 sin a cos b, whereas sin of a plus b minus sin of a minus b is 2 cos a sin b. Instead of the addition and subtraction, if you multiply these two, it gives us a wonderful thing that sin of a plus b into sin of a minus b. I am repeating you. These two we are multiplying. Sin of a plus b into sin of a minus b. This product directly equals to the sin square a minus sin square b or cos square b minus cos square a. So from sin of a plus b and sin of a minus b, you need to memorize all these things which helps you to solve the problems. Whereas coming to the next two things, cos of a plus b and cos of a minus b. Whereas if you look at the result, cos a cos b minus sin a sin b. For sin, it is sin cos cos sin. For cos, cos sin sin, along with the opposite signs. And now if you add these two, cos of a plus b plus cos of a minus b is equals to 2 cos a cos b. You need to memorize all these formulas, right? Cos of a plus b minus cos of a minus b is equals to minus 2 sin a sin b. And see, if you multiply these two, cos of a plus b and cos of a minus b, it results out like cos square a minus sin square b or cos square b minus sin square a. So initially you need to identify these formulas. Along with this, sum of subtraction of as well as multiplication of these two you need to memorize. And tan of a plus b and tan of a minus b. In the case of tan, the addition and subtraction multiplication of these two is there, but it is not much important, right? So tan of a plus b is tan a plus tan b by 1 minus tan a tan b. For suppose if a is pi by 4, so replace a with the angle 45 degrees and b with theta, what will happen? See, then you use this formula. Tan 45 is 1 plus tan theta by 1 minus tan 45 into tan theta. And if you rearrange this tan theta as sin by cos, it becomes like this. Just by using the first statement, I wrote here that tan of pi by 4 plus theta as this cos theta plus sin theta by cos theta minus sin theta. Similarly, if you took the second one, again you have the similar result that tan of pi by 4 minus theta is here minus sin and there the plus sign. All these are the base required formula sheet from the compound angles. And if you have all these things in your brain, then you can find some trigonometric values also. First, suppose here I have that what sin of a plus b is equals to sin a cos b plus cos a sin b. If you take a is equals to 45 degrees and b is equals to 30 degrees, what will happen? If you replace a with 45 and b with 30 here, from this you will get that sin of 75 degrees value. And how it is? Sin 45 into cos 30 degrees, whereas cos 45 into sin 30 degrees. In such a fashion, if you simplify, you will get that sin 75 degrees value is root 3 plus 1 by 2 root 2. So like this, by replacing a with 45, b with 30 in all these things, you will get the values for, what I say. If you replace in here, you will get sin 75 degrees. If you replace here, you will get what? Sin 15 degrees. Then from this formula, you will get cos 75 degrees. From here, cos 15. From there, tan 75. And from here, tan 15 degrees. So you need to memorize all these values also, along with the values from the first conceptual idea. See, 0 degrees, 30 degrees, 45, 60 and 90. Along with those values, you need to memorize the values for the trigonometric ratios, for the angles 15 and 75 also, right? So have a look at this. All these things comes under the second conceptual idea. And one more thing what we need to identify from the second conceptual idea is, I will give you, see, you need to discuss for everything, but for sign I will discuss. Okay? Yeah, look at that. Sin of a plus b and sin of a minus b. And after adding and after multiplication, after subtraction of those two, have these results. And the next thing what we need to do is, from this compound angles, we will develop formulas of transformation. Actually, the name is not required for us, but I mentioned here. See, the idea of transformations is nothing but, look here from there what we have, that sin of a plus b plus sin of a minus b is equals to 2 sin a cos b. See, if you add these two, you will get the first one. And now what I am going to tell you is, you just treat this a plus b as some c and this a minus b as some d. Then it becomes like this. Sin c plus sin d is equals to, if I treat it as c, if I treat it as d, then sum of these two is 2a, but here we have a. So if you rewrite it in terms of c, it becomes like c plus d by 2, whereas it is cos of c minus d by 2. Right? The first thing, sin of a plus b plus sin of a minus b is equals to 2 sin a cos b. And if you rewrite it in terms of c and d, by taking a plus b as c and a minus b as d, you will get these transformation results. Sin c plus sin d like this. Similarly, sin c minus sin d, cos c plus cos d, cos c minus cos d also. You will get all these formulas in every standard book. Just go with the standard book and list out all the formulas. Make a revision. Write with your hand for once or twice. Revise all those things. If you are perfect at all those formulas, then that confidence, that formulas will give us a good result in attempting every concept of mathematics. Right? Have a look at this, and this is the second conceptual idea from trigonometry. I will come with the third conceptual idea. Look at there. The third conceptual idea from trigonometry is about the concepts of multiple angles, and the very simple. In the second conceptual idea, we listed about the sin of a plus b, cos of a plus b, and tan of a plus b. If those angles a and b both are equal, and if you say that equal angle is some theta, then you will get these results that sin 2 theta is equals to 2 sin theta cos theta, whereas cos 2 theta is equals to cos square theta minus sin square theta, and tan 2 theta is equals to 2 tan theta by 1 minus tan square theta. Have you observed these three things? Just by replacing a and b both with theta in the second conceptual idea. Then sin 2 theta is equals to 2 sin theta cos theta, just leave it like that. Whereas coming to the second one, cos 2 theta is cos square theta minus sin square theta. If you rewrite this cos square as 1 minus sin square, it becomes 1 minus 2 sin square theta. Whereas if you replace the sin square as 1 minus cos square theta, it becomes 2 cos square theta minus 1. At the end, for cos 2 theta, we have two separate results. One in terms of sin theta, 1 minus 2 sin square theta. One in terms of cos theta, 2 cos square theta minus 1. If you equalize these two, cos 2 theta is equals to 2 cos square theta minus 1, then you will get that cos theta in terms of cos 2 theta. And whereas if you equalize these two, you will get that sin theta is equals to in terms of cos 2 theta. So this is the analyzation related to the cos 2 theta. Whereas coming for tan 2 theta, and this is the basic one from tan 2 theta is 2 tan theta by 1 minus tan square theta. And after having tan 2 theta, then by observing a triangle with the 2 theta as one of its angle, from there you will get that sin 2 theta is equals to 2 tan theta by 1 plus tan square theta, cos 2 theta is equals to 1 minus tan square theta by 1 plus tan square theta. Have a look at this. If you have an angle tan, if you have the value for tan theta, something like tan theta is equals to some t, if you say, then directly in terms of t, easily you can calculate tan 2 theta value, sin 2 theta value, whereas cos 2 theta also. And have a look at this. You need to observe the pattern involved in these formulas. See, for suppose sin 2 theta is given as 2 sin theta cos theta. For suppose what you say about sin 4 theta. See here the angle becomes half here. Sin 2 theta is 2 sin theta cos theta. So if you wish to write for sin 4 theta, you may write it like 2 sin 2 theta into cos 2 theta. You are all aware about it, this, right? Or for suppose if you take only sin theta, then how to write? You may write it like this: 2 sin theta by 2 into cos theta by 2. Like that you need to write, right? See, and have a look once again. Sin 2 theta is 2 sin theta by cos theta is one formula. Sin 2 theta is 2 tan theta by 1 plus tan square theta is another formula. According to the situation, according to the demand of the problem, you need to select the required formula. You need to select the correct formula and to simplify the problem, right? And now using these multiple angles formulas, you can calculate some more trigonometric values like 1575 in the second conceptual idea. For suppose if you replace theta is equals to 22.5 degrees, what I am telling you, if you replace theta is equals to 22.5 degrees, from there you will get sin 22.5 as well as cos 22.5. For suppose if you replace theta with 22.5 here, it becomes cos 45. and you know that cos 45 is 1 by root 2, and on replacement you will get from here that sin 22.5 degrees value is equals to square root of root 2 minus 1 by 2 root 2, just by replacing theta with 22.5 in this formula. Similarly, if you replace here and you will get the cos 22.5 degrees value as root 2 plus 1 by 2 root 2. And have a look, sin 22.5 and cos 22.5 you have. If you divide these two, you will get tan 22.5 again. So you need to identify all those values and you need to memorize also, right? From the first conceptual idea, the values corresponding to 0, 15, 0, 30, 60, 45 and 90. Whereas from the second idea, you need to memorize 15 and 75 degrees for all the ratios. And from the third conceptual idea, the values you need to memorize are for 22.5 as well as for 67.5 degrees, right? And this is the third conceptual idea. Have a look and I will come up with the fourth conceptual idea.